First of all, before I start, so let me express my gratefulness for you coming here. Thank you for your time. Today I will focus on one simple idea, and I will try to deliver this idea in a very concise and sweet way. I will concentrate on the implication of 5G services and 5G network on the future OSS. This implication is driven mainly by artificial intelligence and by SDN. So far, until this moment, most of the operators, they think and they believe that SDN will deliver the softwareization, will deliver the capabilities to the OSS that are needed for the 5G service provisioning. But what happens within the research and in the proof of concepts and the trials, that there is some failure always happens with the provisioning of the service on the big scale, when you want to process the big data, loads of customers, loads of CDN, content distribution networks. So the key solution to this is actually to combine the SDN, to empower the SDN itself with artificial intelligence. How? We will, throughout this presentation, during the next 20 minutes, we will check the need for intelligent operations. What are the key drivers for having intelligent operations? We will go through the implications of 5G on the OSS, 4 main points. And at the end, I will put a closure, and I will have a deep dive look into the SDN and artificial intelligence combined for OSS. At the end, also, I will try to leave some margin for you for the questions. If you have any questions, I will do my best to answer you. The need for intelligent OSS, a bit of a history. So back to 1970, all the OSS operations were driven manually, were done by network engineers. It was not efficient, people were not happy then, especially in telecom operators. It was chaotic. 10 years later, they decided to deploy computers to networks. In 1980, loads of manual work was shifted to OSS in terms of legacy applications. Still good work, but not enough for what we are aiming to in that era. 10 years later, TM Forum was formed, and ITU, the International Telecommunication Union, the telecommunication sector, actually founded this model, which is the TMN, Telecom Mobile Network Management model, right? And from the 1990, it was the very big boost of 2G services and 2G network. But yet, people were more ambitious, services were more higher, people wanted more revenues, so the technology actually evolved even higher in 2000s. TM Forum came up with an idea, let's evolve our OSS and make it next generation. Next generation OSS was introduced, and throughout the next generation OSS and BSS, the 3G services and 4G services were provisioned. Back to what I said at the beginning, that operators find through the trials that there is some lack of provisioning services at the moment, and that any legacy OSS, even the current OSS, are no longer valid or will no longer be applicable with the future provisioning, with the future 5G services. Therefore, there was the introduction of SDN, by the way, which is not a very new concept, 1995 Stanford University, maybe most of us know the story, but the combination with artificial intelligence, and here about the artificial intelligence, I'm not mentioning the BSS, the basic intelligence, but actually it's a comprehensive, advanced, and approved, loads of complicated algorithms. The needs for artificial intelligence to be combined with SDN are coming back from the basic requirements that we heard over and over from 5G. And I'm afraid I have to stress on those requirements again today, because many people maybe just know the numbers, but actually they have a huge impact on the future service provisioning. 10 times less service latency, 8 times almost traffic is going to pass and be conveyed over the network. 20 times higher speeds, data rates, 10 times spectrum. So actual users and actual operators will be allocated 10 times the spectrum. And at the end, the last point is the dense connectivity, which is 10 times than what we have now. This is mainly deployed by the small cells, deployed by the CDN, content distribution networks. So those services has to be delivered in real time to many subscribers and to process loads of traffic. SDN will handle some of that, but the rest, artificial intelligence has to help with that. What will be the implication of 5G provisioning on the OSS? neatly and quickly. First of all, we have to break the silos of the legacy OSS. Any vertical lines has to be broken down. Integration between the different components of the OSS to provide an end-to-end service provisioning, it's a must. From there, we can go to the real-time. We can be more ambitious. We can provide real-time orchestration. Real-time orchestration is addressed by the first point, breaking down the legacy OSS, but also to add on top of that the microservices, open APIs. Doesn't matter the mapping, 1-to-1, 1-to-2, 1-to-3. We need the microservices. We need the cloud nativeness of OSS. The third point, new service models delivery. This is actually a good follow-up point on what you mentioned about the charging and the billing of VNFs and SDN. That's correct. The new service models has to be also advanced, modernized. The last point, the management of physical and digital resources. Mainly, you need to manage the physical and the hardware. That's what we do today. I mean, 10 years ago we were happy, but now we are not happy with that. The next level is to manage the virtual machines and the VNFs, which is causing loads of headache because you can spin up 10, 20, 100 VNFs in the network to provide a cross-domain, cross-chaining orchestration service. SDN, OSS, in the way it looks today, it's not going to be successful. Therefore, you need artificial intelligence. For the last point in the OSS transformation, the OSS has still to support the legacy, but also it needs to be modernized to support the VNFs and the heterogeneity of the future networks. The points, if we go deeply in the OSS and the BSS. In the BSS, one of the main components is the billing. The other component is the product catalog. Those two components has to be real-time. Customer partial clicks on a button, he wants a car, or they want 10 megabyte more bandwidth. It has to be provisioned now. So the product catalog and the billing systems has to be very responsive on the time. The second point is the whole OSS, when you provide the whole service provisioning, has to go through a closed loop automation, integration, when you go through the process of planning, designing the service, creating, configuring, then at the end deploying. This has to go through a closed loop. The integration requires open APIs, requires microservices, as mentioned in the last point. The service delivery has to be automated, as I mentioned, throughout the integration of these different components. And this integration has to happen on a timely manner. SDN, as I said, it will help you with the abstraction of the forwarded devices, of the forwarded traffic from the control. But what will happen after the control in the management? There is the introduction of the SDN combined with artificial intelligence and machine learning. We call it cognitive orchestration, cognitive 5G orchestration. Fancy terminologies, complicated, it seems complicated. The good news or the bad news depends where you're working, which department. It is complicated. There are loads, thousands, millions of algorithms that need to be implemented in those engines in order to provision 5G services. If we look into the traditional, on the way we provide the service today, there is a static legacy network. You have, the machine learning has four types of four mechanisms. Supervised learning, unsupervised, semi-supervised learning, and there's a reinforcement learning. In the legacy, it is a supervised model. So it's kind of intelligence, but still it's not intelligent enough. It's not ambitious enough for us for the 5G. We'd have static models. So the OSS reads from the network, the basic data. It is modeled, and its input, the input goes manually to the OSS by the engineers. For the 5G, again, it's not going to work. What we have to do in the 5G is to use the reinforcement learning, which is basic on actions and observations, continuous cycles of observations and actions. The OSS has to work on top of the SDN. The SDN control is an abstraction layer, taking reading the data from the network elements, but passing those data to a bigger engine, which is going to process this information. This bigger engine is called artificial intelligence and machine learning. And the reinforcement learning mechanism is the most applicable in this case. One of the use cases or the scenarios, which is content distribution network, CDN. It's a low latency, high bandwidth service. Content distribution network, instead of having routers and data centers centralized in the core or just some specific regions, it will be different. Those routers, those data centers, they will be distributed towards the edge, towards the user, to reduce the latency, to provide higher service, quality of service, and quality of experience to the users. Loads of a massive amount, numerous amount of devices has to be configured. Are we going to configure them in the way we do today? It's not possible. It will take us ages. I mean, if you have 10, 20 servers, 30 servers at the edge, if one server will take you to install, go through the engineer, field service management configuration, it will take you up to 90 days. Then you can imagine about 100, 200 servers. This is a different story. Therefore, there is an introduction of artificial intelligence in this domain. The use case that I'm touching is the zero-touch provisioning using the SDN and artificial intelligence. Basically, you have the router, the edge router. You have the DHCP. The edge router will ask the DHCP for the IP. The DHCP will provide back the IP, all other necessary information. The storage. The storage contains the initial and the basic scripts for configuration, but they are not enough for the API calls. API specifications that need to be installed on the router in order to provision the full service. Therefore, the router will call again the orchestrator, but with the massive amount of data, the orchestrator will not handle the real-time data. The real-time data will be handled by the artificial intelligence, by the reinforcement learning, through a continuous cycle of observations and actions, which will be simulated in a separate environment and then fetched back to the orchestrator, which is going to send the order to the storage to install the configuration on the device in zero time. Those simulations are quite complex, but they are possible, they are doable. So hopefully I was direct to the point. It was a quick message. I wanted to emphasize on the importance of SDN and artificial intelligence to be combined.
What is the message of the slide?
Sorry?
Can you repeat the key message of this slide?
Of this very slide. So this slide endorses, it's one of the laboratory work that we had that proves the zero-touch provisioning. The message is that we need to use SDN plus the artificial intelligence to enable the zero-touch provisioning altogether. Any more questions? At the end, before I close, I mean, we can follow up if you're interested on my LinkedIn, email. Comarch launched recently a webpage called Reinventing Telecoms. We have loads of research work there, so if you're interested, you can download articles, white papers from that website there. Again, thank you for showing your interest by coming here.
Very cool. Thank you. Great job.